price session. I think this is one of the most interesting ones to me personally. I mean, we are putting out $1 million, so we should be careful about what we give out that money for. So the goal of this session would be that we sort of discuss and maybe reach agreement, or at least some sort of pre-agreement on what the rules should be for this proximity price. And sort of as an inspiration, I've put some questions here. There are for sure more questions that we need to answer, but these are at least questions that came to my mind and that we should try to answer. So first question is, what is awarded? So you all know about these conjectures, and I think Giacomo will give more introduction to the conjectures soon, but there could of course be a proof for the conjecture. There could also be a counterexample for the conjecture. Do we award both positive and negative ones? Or for example, for the negative ones, do we only award those that have a direct impact to the proof systems that we care about? What are the conjectures exactly? That's why Giacomo is writing this document with Dan. And then it turns out that some of these conjectures have constants baked into them. And the question is, what kind of constants do we care about? So I think in practice, people just set these constants to 1. And now the question is, what if someone proves that the conjecture holds, but with some larger constants? All of these kinds of questions. Do we give small bounties for special cases? Or do we try to reserve this 1 million just to give it to the big results? Are all contributions awarded with the same amount? Probably not. So if not, how do we decide how much to give to which contribution? Do we, for example, give more to positive results than the negative results, and so on? And then once we have figured that out, the question is, how do we evaluate if something is really a contribution and if it's correct? And so you could, of course, require that the result first needs to be in a peer-reviewed conference, but I think many of us don't really believe that this is that this means that it's correct. But what you could, for example, ask is, what role plays formal verification here? Do we only pay out the bounty if there's a formally verified proof, or do we split the money between people who do pen and paper proof, and then someone formalizes it again? At which ratio do we split it? And then how do we present this, and what is really the target audience? Is it mathematicians, coding theorists that have not looked at these things before, or is it the people that have already looked at it? I think our goal should be to at least reach some people who have never looked into proofs, but they are maybe excellent coding theorists. And so I guess what we should also understand is, while we are making all of these decisions, how does this really impact the security of the systems that we care about, because that's ultimately our interest, and for example, the concrete sound is limit. And if you have any questions that we should add here, then let me know, I will add them.
Probably, I cannot say this here, but I think one important thing to be specified, if it's not in the list, is really the use of AI or machine learning things, or I don't know if it's in that list, because in my opinion this is going to be a bit controversial somehow. We've seen some recent case, and it's like some that doing things with producing anything with machine learning nowadays is like super fast, but trying to assess the things is correct or incorrect can take an order of magnitude more time than producing it. So it's really listen.
But you can discourage them. You can say, like, if the papers are generated, we might take longer to review it, or say something like, we will do additional scrutiny with things which are high.
But if someone says you're giving it to tape and it looks trash, the same thing applies, right?
True.
Yeah, I mean, for a technologically advanced community, as we claim to be, rejecting something like advanced technology like AI proofs, this sounds a bit lame, I would say.
I think the standard is really the same regardless if it's AI or humans. We'll reject human trash and AI trash, and what we care about is quality. So I don't know that we need to explicitly state no AI. We just should state that the quality should be good.
And you could probably add a simple thing that says like you could submit it at most one attempted proof a year or something. So like someone can't send like 1 million AI papers at us. They're gonna send one and they come with a new identity.
Maybe we can come like with a similar things that the Eurocrypt this year. I mean, I don't know if you have seen the Eurocrypt submission rule this year. There were at least like there were sessions that you state how you, I mean, you self-assess how you use AI.
Just adopt the same policy as the ISER. Right?
Exactly.
Yeah, that sounds reasonable.
But
Right.
they operate in a bit different environments. So in ISR, they want to select some number of good papers, and they are okay of rejecting good papers because kind of these papers can be resubmitted at a later conference. We are at a little different situation. We want to accept everything that has a chance to be right, and we potentially have long enough time to look at this. We are not time constrained as.
But self-assess how much you use AI, I don't see it's a big limitation. Say, okay, I use AI only for editing, or I use AI to, I mean, you can cheat, you can say the things is not true, but at least like putting a self-assessment of how much you use AI, I will put it.
I would
But
say
you would never choose what to review or not to review based on that self-assessment.
No, but at least like being written explicitly where you use AI for, like only for editing, only for like the table.
Maybe we're trying to solve a problem that hasn't appeared yet.
Well, technically it appeared already.
Yeah, there's already a submission.
Yeah.
Someone already said that.
Yeah, but is there a problem?
Well, it took me like 2 days to figure it out, but no,
Really?
not today, but I spent some time.
So I think the thing that we want to get rid of is like these spam submissions, and limiting the amount is a good idea. I think in the end we don't really care whether the result used AI. Like if it's correct, we are happy, right? So
Maybe one question about this would be like, for example, are we allowing anonymous submissions? Because as a community, I think we like that, but if we want to do like some spam limiting, then this ends up giving problems. So there's a...
You can do pseudonymous submissions as long as they're tied to a pseudonym that was previously active. Like if someone has a GitHub repository where they've been doing stuff for the past few years, then the pseudonym is fine.
Yeah, so like you're saying, like I cannot create a fresh GitHub that was not existing.
I think like anonymous submission, I'm all for it, but I think they will fail. I don't know if this is the case. The Ethereum know your customer.
Yes, they will fail.
They will-
1 million prize will require KYC.
Yeah, so they will fail it.
Above 10k is KYC.
Yeah.
Well, we don't really expect an anonymous submission which satisfies.
I mean the last guy. I mean this kind of who is this? I mean this is like
Maybe
paper.
it's she wakes up. You know.
Since this is a cryptocurrency, can't we have a prediction market? It needs to hit some threshold.
I mean, it's not here.
Yeah, but we saw this with was it the superconductors or something? Prediction markets were going all over the place.
It's a spam prevention mechanism.
Oh, you mean like we only consider submissions have like above 50% on the prediction market?
Yeah, something like that.
Sure. Yeah, I mean it's a good test of prediction market spam resilience. How much capital?
Seems
you
quite
can
imperfect information. Like I assume like most of the people in the prediction market won't really understand.
Well, how much would it cost to get your submission above 50%? Because it might not be that expensive.
Yeah.
I have a quick question. Is there any work on potentially easier problems, like proving a reduction to a known problem, or I think it was mentioned earlier today that there were certain parameters that were particularly interesting. The reason I'm asking is because usually I think with these kinds of prizes, maybe the problem is really hard, and even if there's just like a certain implementation specific or very narrow scope from a theoretical perspective that wouldn't interest theorists, might be a game changer for us. So maybe it might be productive to just have like, here's like 3 or 4 tiers of what we think are relevant, and if you can show these 2 or 3 special cases, we're gonna give you some money.
Yeah, this is possible. Like this theorem, from my understanding, like they don't really reduce much. They're kind of like standalone, like big problem in coding theory. Like I don't know, for example, of like equivalent formulation of this decoding for Solomon codes, which implies what we care about.
I think there could be a boundary, which is if you show some reduction.
Yeah, there could be like we have a lot of options for these kind of things. Like there's also like classes of attacks. In fact, later when we talk about the problems, there are like some toy version of attacks of the problem that one can try to analyze. think relatively easy techniques, and then you can start getting limitations. There's like a lot of like things that one can do in there.
Just to put on the agenda, I saw that there was talk about disqualifying certain characteristics or something like that. I don't support this, but maybe add this to the list of topics that.
Yeah.
I don't know if this counts as parameters or.
Can you repeat what should
whether I think Ulrich thought that flagged that maybe in characteristic 2 it would be easier to disprove.
Yeah, we have some limitations in that, like in characteristic 2, we actually know the sum of the, for example, I think in list size, in list size you get like some, you must get like a factor of n in the numerator of the error, while in the prime field case you don't get this thing. So the large characteristic and the small characteristic case have some different thing, but I think this is mostly like, maybe we should like divide, so there's the parts which are about bike shedding, so this is like a rule of the price, they're kind of like agnostic of what the problem is in really, and then the things which are like about the price, which is kind of like the scope of what we want to audit. So these are like parameters, the field characteristic, understanding the counterexample existing in the literature, the numerical parts. So I think it's like two distinct things. So one part to solve first is just the bike shedding, like when are we going to give this them money, if we have to. And the other one is like parameters and figuring it out. But yeah, so there is some difference between the small field case and the large field case that we need to account for.
A little step aside, when a couple of years ago, we were trying to organize something for Poseidon. Well, they're not that big, but for example, I approached many prominent symmetric cryptographers and asked, well, why are you, man, with so big like number of citations, why are you not trying to go to a workshop and try to break Poseidon and try to write a paper to motivate a student or something? Many of them explicitly told me that there are like two big reasons they are not participating. First reason is that like this thing is too short, so that they cannot, for example, hire a PhD student to work on this because it will end before they even hire it. The second thing is that this idea, this initiative may be well known in one particular area, but not very well known in general community, scientific community, so that it's difficult to, for example, ask for a grant or mention it in a grant that doesn't give you immediate benefit and so on. So what I'm hinting at is that first of all, did we consider already like pre-approaching different people and ask them what would motivate them to work in this area? Because in many times it's not only the money, and maybe they already have the money, or maybe they cannot use the money, but they can use of something else. I don't know, we can help them hiring a student, write a grant, I don't know, whatever. I'm not very close to academia right now, and I don't know what exactly they need right now, but maybe we can try to think a bit outside the box and maybe suggest something else aside from the money to like prominent people who can take part in this.
Yeah, this is something that in part we want to do. So one of the reasons, the formulation I was thinking of was to make it very mathematical, because at the end this is like a very nice problem of polynomials and something that should appeal to the wider mathematical community. We've independently been like already talking with some of like coding theories people, like for example, Mary Wooters at Stanford. We talk with Svastik, we talk with a few people which have experience in the field. So the conjecture, so there are two problems that we are kind of interested on. One is the list coding and one is the proximity gaps. And list coding in particular is a very well-known and wide coding theory, interesting like conjecture. So we think that by making it like both the problem very accessible, sharing it widely, for example, one of the plan was to advertise it in the journal of the ACM to like the American Mathematics IMX, that's the one. ACM is the other one. We want to try to get like a wider community, plus the prize usually gets some good attention. But we'll also try to like talk with more people outside of the usual, like maybe something that we could organize is like a press tour, like going to different universities, trying to like go to different like mathematics department to try to like actually advertise the problem more widely. So this is something that could be interesting to do.
This is not really a great cryptography problem in this. Like I feel that it's like more different community than the people.
Absolutely, this is a problem about polynomials. There's no cryptography, there's no security parameters. You know.
And given this, I mean, why do we even allow pseudonymous or anonymous submissions? Because we know it's not like Bitcoin, which solves a societal problem, I would say. So we would even say here, non-anonymous is fine. That's my personal opinion.
Yeah. So, who suggested anonymous? Whoever did that, can you repeat what the motivation for that would be?
So I mentioned it just because I think like you know this first AI submission was an anonymous one, and in the community, you know, there's some anonymous figures that were prominent, let's say.
I would really forbid this because like whenever it's not like one round protocol, right, to get a prize. You have to interact with the person like back and forth. You have to present these results around. Some people may not be even comfortable to kind of give money to.
I mean, maybe reviewers should not see the name, right? We should. Well, like if I don't know if someone submits something and Giacomo says, okay, I will review this, but I will also give it as a sort of external review to I don't know, Ulrich, right? And then maybe Ulrich should not see the name.
Maybe it's okay to see the name as long as there are like really many people working on each submission, and you have like a diverse use. Just with redundancy, you ensure that there is no censorship, like we do this in signature aggregation.
So I think I prefer, I wouldn't say allowing anonymous, but not forbidding anonymous. Basically, because I think we should give all submissions equal chance. Now that's not to say that we're obligated to read any submission, even if it's not anonymous. So if some public person submits us something bad, I don't think there should be an obligation to read that either. But if we start forbidding anonymous, then it makes it feel like we're promising to give you time if you aren't anonymous, which I don't think we really want to do that either. So I don't see why we should even distinguish between these two cases. I don't think the Clay prize has any stipulation one way or the other. And by the way, I mean, for the Millennium Prize, I don't think there's any committee who's promised to carry out the review, right? How does it work for them? Isn't it just that the community has to accept it? In other words, Clay is not undertaking the review process themselves. They're kind of letting the community do it. Maybe we should try to do something like that.
Then their cases probably takes much more time. If you
Well,
don't
It's
care
$1
about.
million, bro. It's expected to take time.
Why can't we also take that much time?
Well, because we did it kind of yesterday. I'd say, well, not yesterday, but tomorrow really. So we need this to make sure that our ZKVM things run securely. This is definitely not.
But I think
10 years.
there's a sense of like, okay, we have a submission that's really good and we feel confident about it, and so we're happy with it with our ZKVMs, but we're also happy to wait an extra amount of time to see if anything comes up before we actually pay out $1 million. Right? Like paying out $1 million to something that ends up having a flaw seems much worse than paying out $1 million later.
How's it with the leanVM? Because I know just from the big projects, it's not a showstopper to move from conjectured parameter settings to provable ones. So it doubles the proof size essentially. So what's your thoughts in regards of the time, the quite strict time frame you have given from a slot for the leanVM?
I guess it will, the proof is easier and maybe a little slower because in Weir, if you have more challenges, you have to compute all these equality polynomials. So weird would be slower and proof easier, but I mean,
It might be worth to think about because then one has always a fallback solution. Just considering it's gonna be TIS-proof, not saying it's.
Yeah, but I don't think you want to think like, oh, we want this to be true within the next year or so we kind of feel incentivized to give out the price sooner rather than later. That seems like a bad idea.
Something that I noticed, I think, for other big open problems that they do, for example, I think the P versus NP problem, is that they have certain subclasses of proofs that are known to be broken from the very beginning. I know they're doing a lot with stat solvers or something there. If it, it might be productive, and I think this goes back to the conversation around spam submissions, but not so much malicious, but rather some people are all gonna stumble into the same thing, and they're all gonna submit that kind of thing. So it might be worthwhile having some kind of technical document where we say, we know for a fact that A, B, C, and D as potential avenues are gonna fail, and here's a proof, or this is what we think, and please don't submit those because it will be an automatic rejection.
Absolutely, it is something that we can do. The kind of one of the issues that we, for the P versus MP, there's like mountains of literature of people that try to do it.
But they also have a bunch of like very rigorous method complexity theorems, right? So
Exactly.
they have a precise sense that the proof cannot be simple.
Yeah, like algebraization, all these kind of like techniques. In our case, I don't think that I know many strategies which I can tell you like, oh, this will definitely not work because this breaks some other barriers that we have. Like we don't have this sense of barriers in the complexity theoretic sense that we can like, there's not this web of reduction. It would be worthwhile for somebody to like think about them, which strategy can work.
I mean, we could publicize submissions and then.
Maybe negative results can be incentivized as well.
Yeah.
In a different.
Yeah. We can have bounds and negative results. We can publicize submissions and like some kind of review of the submission that says this tried this technique and it didn't work.
Yeah. Do we want to put some upper bound on the complexity of such a proof? Like, kind of, we require that a proof can be read and understood by a single human being within well.
But I think this is implicit, right?
Are you trying to avoid the ABC case or?
Oh yeah, they haven't worked on theory.
I mean, they could just give a snark that the proof is correct.
No, I mean,
and if you prove it in league,
avoid some proof that is supposed to be like machine checkable or something, like if you go over all these 20,000 sub cases, then.
But I think this is implicit in the fact that like if you say we also won't pay out for proof that we're not confident in, then clearly if anyone can understand the proof, it gets disqualified that way.
Right, and that's also one of the motivations for having a formally verified proof as the ultimate goal. Like maybe just giving part of the money to a handwritten proof or pen and paper.
I don't know if we really want to force people to formally verify the proof. I mean, I sort of
it
the
would be
opposite.
separate.
It
Like-
could be someone else, right?
Yeah, but I mean, like, I feel like the proof could be arbitrarily complex, provided the community understands it. I don't necessarily see the issue of not formally verified.
Right, you would still. I mean, at least
No,
that's
you
how
would have,
I
like,
would.
a huge
You would
payout
still get
for having
get
a
money,
confident proof.
but you would maybe would reserve some amount of money for someone that takes this proof and then formally verify.
And like the process of making it amenable to full verification would improve the readability of the proof by quite a lot.
Yeah. If we're in a good position where we get like actually a proof, we can also make the choice of like, we look at the proof and we say the building blocks are already in our clip, for example, then we can just prove it directly. Otherwise, if it is like a pain, then we can maybe put a bounty out of it for like the formal verification. At this point, we can make the choice that we want. Like,
I guess what I said is that if we have a proof that the community is accepted, I think they should get the full bounty. And then if we decide as a community that we also want to formally verify it, that might be something we do in addition to this. But like sort of the Millennium Prize problems, you get the $4 million. Like I don't think any of those have been formally verified because that's a no.
The requirement.
Now the Stokes is coming.
It hasn't necessarily been proved yet, right?
They're working on it.
I mean,
But definitely formal verification should not be a requirement for like winning the prize. I do believe that if somebody wins the prize, then we should formally verify it. But yeah,
it's a separate thing. Like,
Yeah, that's what I mean. I think that should be like something we do after we've awarded the prize. Like once someone has the thing and we've given them money, we can be like, okay, let's put some money inside and see if we can hire someone to go and formally verify this.
So on every price we impose a VAT in verification added tax. 20% for the server.
A question that one can make, okay, if somebody sends us a lean verified proof but no pen and paper proof, do we accept that?
Oh yeah.
Yeah, which would be amazing.
I mean, it's easy to check.
Yeah.
Just for comparison, have the current results on correlated agreement been proven formally yet, and how much work is that?
They've been stated, not proven yet.
Okay. How much work did they represent stating it, and then?
So stating them took a bit of work because a lot of coding theory was missing from Maslib, but now that's been done, so Katie who's here did a lot of that. So now we're able to state them, and then for proving them, it's probably like a matter of weeks or months. It's not some insane effort. Okay. It's definitely doable.
I assume that some the delta over free lemma, for example, should not be too hard, while if you end up going with the crazy fertility gap one, then there might be more challenges.
Yeah, that's kind of the question.
But I think
also a
Johnson
good motivator for people getting into a problem.
Yeah, so Johnson bound, for example, is done right, and that wasn't some crazy effort.
Okay.
You mean UDR or?
No, it's too big.
It's just the Johnson original.
And in this,
not like a
what's the state
protocol
about the UDR up to unique decoding radius?
No, that's not done yet.
Ah,
Oh, you need to code
I thought that was much easier.
Yeah, I think we just need to prove what the Johnson bound is. Do you mean you've proven, what about the Johnson bound if you've proven?
So
yeah, we basically have that read zone on the codes decodable up to the Johnson bound. That's what we have.
Sure.
So by decodable you mean the Guru Swami Sudan decodable?
Yeah, it is decodable.
So constructively decodable.
Yes.
Because this decodability just means that the number of the list size.
Constructively, but like
There's some non-computable definitions in there.
existentially decodable. Like
Okay.
we
Efficiently
have proven the bound on the
decodable.
list. No, not efficiently.
Ah.
It states on it that there exists.
But that's just
like the intersection of the ball,
Yeah,
the
okay.
bound radius with like.
so you verified Johnson's theorem.
Yes.
Right. Okay.
Is there any interest potentially? Thank you. Is there any interest potentially in actually running, like, I don't know if you guys do this already.
Simulation, yes.
I was actually going to say like workshops at very specific places where you can just, hype this up as a real question. I know you mentioned that it sort of transcends fields in a very big way, and sort of cryptography doesn't really seem to be the most relevant one. So potentially, to get smart people to look at this, it might make sense to have some sort of continual kind of either budget or workshops to deploy into it, because it just feels like then you can only get submissions from people that know about it. It might solve a lot of these social problems.
Absolutely, having large, trying to advertise it to a wider community. It's something that I think we should do. I don't expect this problem to be solved in the next year or the next 2 years and so on. So, if we manage to, once the problem becomes large enough that people care about it, it's nice. So then we can start thinking about workshop, thinking about budget. But yeah, I think all of this start with a very good formulation of the problem, very good submission guideline, and very good initial advertising of what we do here. And I think I think we can do a good job there.
What about this big computer science conference, I know, Fox or ICAP, yes, or ECCC, this sort of things. Do they have RAM sessions or something where we can just come and announce? I don't know.
Yeah, definitely we can do. We can we can advertise it there as much as possible, and then we see how things go there.
circling back to formal verification, just a quick opinion from my side. I would guess it makes sense, even from the practical targets, to first verify the much more succinct proof in the unique decoding machine.
Yes, that's what we're doing.
Sorry?
We're working on that.
Ah, okay. Oh, you're doing it anyway.
Yeah, we're doing that
Ah,
regardless
okay.
of all this.
Okay, good.
Sorry. We're just waiting to have all the constructions and the ability to take everything in place.
I think it would be interesting as well.
It would be interesting as well if the process goes for quite some time to run a sort of like C-fail stuff of like we get these best approaches that were very interesting, they didn't achieve, but this can inspire further ideas or something, and this can also be a sort of like promotion.
I think that's something that we should do. Like I love CTAL. It's one of my favorite conferences and sessions, and I think something that we should do. Like one thing that we could do, we could set up like a website where we end like all the submissions get sent and time-stamped, so we know that when people get priority, and then we, for those submissions which are like broken, we do a post-mortem, we write it there, and so we have like reflection of methods which do not work, plus submissions of like failed approaches. This is like all things that we should do, and I think this will very much benefit the overall approach. Another part that I wanted to mention, which is quite important, is that I think this kind of conjecture, they need to be like very much verified numerically. So on this, Antonio started like working on this, and this is also something that even the people which are a bit less theoretical but good with code, which is not me, can help out with. And these conjectures, as far as we know, they will hold like for very small fields as much for large ones. So we would like to run a lot of numerical experiments, possibly continuously, to try to figure out whether the conjecture that we're making make any sense at all in these small cases. And this is something that I think Antonio started it like I had a parallel CPU implementation we start with. I think there's a lot of tricks that one can try to play, and this is something that if people are interested in, this could be a good thing to also jam on during this session. I think because it needs like relatively little like background to start with.
There's a whole journal of experiments in mathematics as well.
I didn't know about that.
Deals with this.
Yeah, we could do it, and then
you can set up special edition.
Yeah, and submit it.
So it would be cool to they have these distributed searches of like large Mersenne primes or something. It would be kind of fun to. It would be a lot of work, but to set that up to search for search random affine lines and search for close points or something like that, right?
Absolutely. Like I think this is nice, and we like in general, like I think. Let's start with the simplest possible experiment, and then later on we can like start bolting things on top. So that's one of the things that I think we need to do that. And the other part, like figuring out like the state of the literature for like the counterexamples that exist to opportunity gaps and to list the coding, figure out which implications we can impose. So once we have like a kind of like very nice footing on the theoretical part, I think we can be confident in the problem statements, and then from there, like we can get everything out. Like
Maybe one question we talk about like problem statements that I want to revisit is this range of constants. Like for which range of constants does it make sense? For which range of constants do we want to pay out money?
My personal opinion, and I think I shared this with Dan, is that constants get better with time. So for a lot of these results, like the capacity result in particular, the barrier is a lack of techniques. So we really don't have any techniques to go from above Johnson to capacity in the settings that we care about. So the breakthrough would be like getting the technique, and then if the technique gives you n to the 8, it is most likely because the technique will end up like, because the technique has not been optimized yet, and then people will optimize it. So my personal opinion on this is that we should try to give like very clean, very asymptotic style result where we don't care too much about the constants, see what happens, and then if we end up like if we end up getting at a point where like we find a proof, which anyway would be already amazing, with bad constants, this will probably be many years in the future. Then if we really want to optimize the constant, we do another bounty.
Can you remind which constants?
Yeah, very dumb question about the constants. Like, when they get very big, does the gap still exist? Or like when the constants get very big, there's no gap anymore?
Well, so for example, like some of these constants are like the form evaluation domain size over side of the field.
Yeah.
If this evaluation size to the 100 over side of the field, well, then for most fields that I care about, this is like meaningless.
Yeah.
So this constant that we're talking about is the errors mostly.
Yeah, maybe worth it to show them on screen or show the formulation on screen.
Yeah,
I can try to do that.
You have a link on the HackMD itself. There you go.
Yeah, so this is like the old one.
He's trying to answer.
But yeah, so this is the kind of like error that you kind of like end up getting. So this is what is known and proven. So we.
I think if you scroll further down, there should be like. There you go.
Yeah, and these are like some of the conjectures that one can think about.
These constants, right?
Yeah, these are some of the constants, for example.
We got a question after.
Yeah.
Here's for this. Sorry, for this side.
I was just going to suggest that if to fight spam, instead of putting hard requirements, maybe we can have things that that help us to rank all the submissions, and maybe if you get some review, some professor, we consider you, we give you a little bit more priority, or if you don't do it unless if you put your name, we give you a little bit more priority, and that way you don't block anybody. But if you have too many, you have a way to know where to start.
Maybe that's something that also we could do. Yeah.
But there's no commitment to review submissions based on arrival time.
I think what we should do is that submissions,
like when you
they should be time-stamped anyways. Sorry?
It's like when you review for conference, you look at the papers, there's like more interesting stuff.
It's true. I think there should be like some timestamp when people submit the paper, just in case there is conflict.
Yeah, for priority, but not for reviewing.
Not for reviewing, no. Like,
because also some will just take more time to review.
Absolutely. I think in general, like a submission should not like commit the reviewer to like any timeline for when they review it. Like we get to it.
Or unless the only way you would do that is if there's a timeout where if it takes too much time and you have an interesting conclusion, you just assume it's wrong.
Yeah.
Which is.
I think the situation is going to be way more convoluted than we imagine. I mean, even like all these submissions, it's not submission, but the paper that Jacob was mentioning before, is clearly machine learning generated, but I read it, it contains some deep stuff as well. I mean, it's not really clear what is good, what is not. Some things in that paper are actually pretty good. I think Giacomo agrees on that. To me, in my opinion, it's going to be pretty convoluted to review. I mean, that's what I expect. I will not expect.
Yeah, I just don't think. I think this is just the way it's always been. I don't think anything's fundamentally changed in that regard.
So I guess one question we have to think about is like, how tied are we to the specific statements of the conjecture? So I know, for example, for these conjectures, usually you assume something like, so the proximity gaps are saying like, if a random fold is close, then the things that were folded are equally close. And I know there's also been work recently on stuff like, if the random fold is close, then there's stuff is not quite equally close, but almost. Like, there's probably lots of places you could add deltas and epsilons into these sort of conjectures. Do we want to be like very willing to, hey, if you have something which is basically, because I think most of these deltas and epsilons are good enough for our purposes. So like we could say if you prove a conjecture that like is good enough for our purposes, it's fine, even if it's like a bit weaker than what this is, or we could be quite strict.
Yeah, so it's a good question. Like the epsilon, there will be like there will also be these kind of etas, which are like another part which you need to do. There's the preservation thing. So one thing that we could do, and that I was planning on to, is like you can write very simple version of like the protocol that we care about, which you can analyze under different version of the conjecture, and it will give you different like bounds. And depending on like, so this should one tell us exactly if these are the conjecture that we care about, and two, it also will tell us what the so we can get some bit of security, we get some security. So for example, one proposal that we could do, and I was thinking about, is that for counterexamples, right? So we can have for counterexamples, we can have that we only award money if the counterexample ends up like lowering the conjecture security of some like toy protocol that we design. So we do a toy version of Word, say for example, and say, oh, under these conjectures, this gives you 128 bits of security, and then if I give you a counterexample which lowers it from 128 to 125, then I pay out.
But do you
some parts, maybe not all of it.
So who is convincing the reviewer that it really lowers the soundness? Because if you say that the people submitting it have to do that, then you rule out coding theorists. Again.
Sure, like you can, what we can do is like if you give me a counterexample of say you write a paper which gives me some lower bound on the things over there. It's also the question of the attack. Okay, I assume that let's assume for now that attack is because in theory there could be the situation that Elon was talking about before. There is information threatly things work, but it's not a constructive attack, so we don't really know how to deal with that. So one thing that you could do is then like, if as a trivial consequence of the lower bound you get like a lower number of bits of security, then this is something that the committee can take care of. Like if it's, in some cases I can figure out how it goes down. While if instead like is very non-trivial, then for exceptional prices, exceptional contribution. So you as the coding theorist will have to take care of it. We can help with that, but yeah, something like that could work.
Do you think that we can, to make this conjecture a little more specific, to make sure that it smoothly continues the upper function?
Well, the issue that we don't really know this is tight. This is like
yes, but we can at least kind of for different constants we can select like outer constant factors, so that this function would be like a direct continuation of the upper formula, just with different how do you call it, derivative basically.
Yeah.
Okay, it would be nice for them to like it somehow.
Yeah, well, maybe if we we know that like we have already proven it like this, and then depending on C1 and C2, for the next segment it should go like either this or either here. And what is in this range is a proof, and what is like here is a counterexample.
To me, like I would like really, my opinion is that we should not specify the constants at all. Like you just really make a very asymptotic statement, like there are some constants. If there are 1 billion, okay, that's a pain, but still a constant. And then this constant will get better because the universe is the right place, and 1 million is never the right constant.
Why? Can we kill L here? Like,
yeah,
why not just use that fine line?
Yeah, L we can kill. In this word part, we use L because we needed it at some point. But if you look at the EF Millennium repo.
You mean set L equal to?
But I'm not sure if you can really kill L all the time.
Is there a generic reduction from the case of lines to the general?
No, I mean if you, I think if you do like batched thrive, for instance,
No,
then the question is how do you batch? Do you batch?
L is not the list size.
L is the length of the batch.
Yeah.
Right? So if you prove it for L equals like 1, then or 2 or whatever. Then
You need two.
Yeah.
But 2 does not like so. Lines do not give you powers.
You get. I mean.
There's not a direct
not generically.
I mean, what you get is, I think you did it in one of your work. If you have the linear combination, you can do multilinear combinations in a black box manner. That should work also up to. I think it should also work in LDR. But my feeling is, my feeling is, with arbitrary powers.
But that's basically what I'm saying. Is can we just care about the case of lines?
I would say so.
Yeah. So at least for like for things like Word, for example, you are fine with lines because you're doing multilinear batching. You can prove that this is fine, like even outside of Unity coding. There's a paper that's gonna come out in hopefully a week or so about this. I don't know, I've heard about it, but basically. For like multilinear things, lines is all you need to prove. this is minimum. If you want to like get arbitrary polynomial combination of the randomnesses, then you also need powers. And there, as far as I know, there's no reduction between powers and the lines directly. But yeah, like in general, like you don't lose much by doing the multilinear folding compared to the powers folding. You use a bit more randomness, but it's logarithmic, so who cares? And it's still usually good enough. So, like, but yeah, so in the actual document where I'm at the moment working with the literature, I looked at the case where we were only combining two functions. This makes the things much
I think the simpler, the more attraction.
Exactly.
Yeah, maybe for the beginning we can have just L equals 2, and then after a couple of years, when you have...
No, we only pay out if we can also prove. Now we have the guy who proves.
I wanted to suggest something for the tax. So now that's proving also disproving the conjecture. I wanted to attract also like people from the cryptanalysis community and not only like mathematicians and theoreticians.
Yeah.
So I think you talked about a few practical things, right? Showing the security bits goes from some toy weird example like reduces. Still, that seems like, how do you convince me? I wanted to propose something that's maybe more practical, okay? Let's even think about Listy coding, okay? Like this, slightly simpler than this. If I claim that the Listy coding bound is fixed some, sizes, some field, everything, okay? Conjecture says that this is the Listy coding bound, okay? It should not have more than 2 to the 40 code words.
Yeah.
Okay. I claim no, I want to disprove it. So now I can give you a word, right? And then you can kind of hash the code word. You expect that if you hash with, and you see something that starts with more than 40 zeros, then there's not going to be anything in the list that hashes to something that has more than 40 zeros. Kind of like gold versus Ipser lower bound. So you can actually just have a code, right, where somebody gives you any word that he wants, okay, and then like this defines the list decoding around that word, okay? So he has to give you something that hashes to enough zeros and is delta close to the word that he gave. This is something that you can just have a code that checks if he's correct, right? He doesn't have to give you a formal proof. He might do this using some SAT solver or something. I don't care how he did it, right? I don't need him to formally prove that what he's doing is correct. Okay, I just need it to work with high probability, and this you can efficiently check.
Yeah.
And if he does that, he disproved the conjecture, and I'm like fine giving him some of the prize.
I mean that's great, but there could be people disproving the conjecture in different ways, right?
I'm saying this.
I don't know,
I didn't say this is the
probabilistic
only
method
way.
you find.
I'm saying this allows to attract people that don't want to write a formal proof that they disprove the conjecture, okay? But they know how to practically disprove it, okay? So that's like a different avenue of getting prize. Use AI, use that solver, okay? Find me a code word that hashes to enough zeros and is close enough. It disproves the conjecture for this setting.
Don't you can't you get win just by trying a lot of different inputs?
Yeah, so you're gonna to get the prize, you're gonna run this experiment many times and see that he kind of succeeds with high probability or something like that.
So is the goal that it's more easy to check a disprove than if they send you the whole list or something?
They send even the code, right, or something like this. And yeah, that's easier to prove
it's the
than
grinding,
for them to
grinding
give a formal proof.
But why don't they just send the whole list? In other words, now you're relying on the hash function being secure, and they in other words, you could get lucky and find a nearby word that hashes to this many zeros, but that doesn't mean there are 2 to the 40 words in the list. It could be smaller and you've got a lucky.
Well, yeah, but this is something you can make sure happens. So you require enough zeros, and you can make sure. But I'm saying like don't be lucky. Send me a code, okay, that gives a word, and then every time we let's say we sample many hashes, okay, and each time they have to like do this. So we can amplify the soundness of this protocol.
So it's
But
not
I'm saying
really
this
a
is
proof.
something they can heuristically try to solve without trying to write formal proofs. Oh, why is everything?
But they could also, yeah, okay. I mean, a simpler version of this is they just try to find all the close words and forget about hashing. Just list all the close words.
Yeah, but 2 to the 40, 2 to the 50, 2 to the 60, right?
I thought it's supposed not to be a proof, so we don't care if the candidate even has a full list. So just by the grinding principle, with high probability, the list size is bounded. Is that the idea behind your proposal?
Explain again.
I thought, so you demand, if I got it right, you demand that the candidate just gives you a close code word which has hashes to a given prefix, which is a small prefix. And just by the possibility that the person manages to solve that problem, we can say with high probability list size is bounded either.
The list size should be bounded, and that's why there should not exist any code word that hashes 2 enough zeros in that list. Yeah.
Now I get the way of, okay.
Potentially.
So this is, but still it's not a proof, but it's something,
heuristic.
it's an argument, yeah?
It's a heuristic invalidation.
Yeah.
Who picks the challenge point that's not the code word?
They submit a word. They submit a word and another close word that both hash to, or the close word hashes to a bunch of zeros. Or maybe their hashes are similar or something.
Can't you just find some over here by...
But they need to be nearby in the code.
No, I mean the hash that hashes to zeros needs to take as input also some challenge that comes from the very first thing, right? Otherwise you could.
Yeah, you choose a word.
Otherwise you could just choose a code word and something that is close, and then you take that.
Or maybe you hash them both.
I mean, it's just
zeros.
it's just an interactive protocol,
It's an
right? And you
interactive
make
protocol
it
that's featured
non-interactive.
yeah, but then we're just asking for smart proofs for this.
Yeah.
But how many iterations you will need in total? Just one?
Do a
I
journal
don't know.
Enough to convince the community.
You have to make sure that an error is like very small, so it's not somebody winning money just by some chance.
I easily imagine that it's like sort of rare to find points with a larger ball than the bound, but so like if you, the judge, get to pick the word that they need to find something close to.
No, they pick the word.
They pick the word.
Yeah.
They pick the other element of the ball that hashes to many zeros. Or maybe you should hash the word and the other word, and then both should have
But isn't I thought your point was now I get to grind on like both picking the word and just
So what? So
No, you first get a challenge.
Think of it as an interactive proof. Okay, they send a word. Okay, at this point in time, they're committed to the list decoding around this word. Okay, if the convictor is true, then there's only 100 code words around. Okay, if there's only 100, and then we say, okay, bring us now back some code word that hashes to 40 zeros, then there's not going to be such a
It's equivalent to hashing both words. So take two nearby words, hash them both, and get a bunch of zeros out.
Yeah.
Shouldn't that be equivalent?
No.
I think that, yeah.
No, I don't think so. Right? Because then you can just take a code word and something that is close by and hash it, and if it doesn't work, take the next code word and something that is close by and hash it, right? So you need to do it in this round by round way. But I think we are getting sidetracked here.
Look, we don't semantics write it down, but I agree. Like I think that
It's a nice idea.
like look, if somebody can that's actually better than a proof code. That's actually an attack, right? I can run fry with that and is an attack.
I'm gonna say people can come up with whatever tax they want as long as they explain it.
Exactly.
So, so to say it again, what does this prove, or what if someone cannot find this? What does it?
No, this is like an additional way. So there are many ways to disprove the conjecture. So one way is disprove it. So you give like
This disproves, but if you cannot, if I provide such a code, it disproves the conjecture.
Yeah.
If no one can provide such thing, does it say anything?
No, because it's just that we're not good enough.
I mean, this is just a succinct argument of knowledge of a counterexample.
Yeah.
Is it that?
Yeah.
Yeah.
It's a way of not sending the whole list.
Yeah.
But if no one
This
can
being the
find,
witness
it
for-
doesn't tell us anything about the list size.
No, yeah, because
Well, maybe it makes us more
It's a witness
positive.
for a large ball around the code book.
the problem is in CoMP, right? We can find a easy witness of no membership, which is interactive proof, while finding to show the conjecture, I have to show that every word has like a small list. While for like the counterexample, I just need to find one word which has a large list, and this is an easy way to show that this one word has a large list.
Okay. And we suppose that if there is a counterexample, it can be just one particular word, not there like
Yeah.
many of them.
Yeah, like in general, I think that if you tell me that there exists a word with a large list, then I can just, as the proof, I run my protocol using that word as my the thing I commit to with the oracle, and then I try to play a game with it.
And there is no way to amplify such a word, such a ball, like to kind of copy it across.
The conjecture is that all balls are small, so if you can find one that has a large intersection, then that's already a disproof. Is that your question?
No, I think it's saying like, suppose I tell you there is one large ball.
Then can you leverage that?
To say that there are more than one large ball.
Yeah, because read-solvent codes are like identical, right? You just add on code words.
Yeah,
You just add
exactly.
code words and you get the whole thing. If you can find one thing with a large ball, then you can find lots of large balls, because you just add code words.
Yeah.
Yeah, that's what I actually did.
Yeah, and I think you can do that.
What if random words have small balls, but there's a specific word that has a large ball?
So there can't just be one. Once there's one, there's a lot of them.
Yeah, but if you pick it randomly,
Sure.
if you pick the word randomly,
But
you get-
the prover picks the
Prover
word.
picks the word.
Mm.
Like the person who's providing the counterexample picks the word.
But if we are using these results in a broader context, like a start snark.
Yeah, so that it's possible you could come up with a counterexample, but like our stack isn't broken.
Yeah, exactly.
Yeah.
No.
I think this is, yeah.
Very dumb question. This is about the list size conjecture, right?
Yes.
Not the
Correct.
mutual correlated agreement.
No.
Yes.
Are they both under the Millennium Prize, or is it just the mutual correlated agreement?
Yes, so
I think that's a good question.
yes. So currently the plan. So when you're working with like things in list decoding, like a Wurst or a Fry, you need some list size bound somewhere. So currently the Millennium draft, if you can go to the document, sorry. If you like, what I've been writing down is having both the Millennium, so both is the two variants of the list decoding conjectures, and then there's the at the bottom of the document there's the mutual correlated agreement conjecture. At the very end here.
And so is the prize for both simultaneously, or just one of them? Does it get split?
No. I think that what we should do is split the price on like this part, because as far as we know they are related because they're both about codes, but we don't have any formal guarantee that one implies the other. So I think it makes sense to like each excluding either of one of them would be a breakthrough.
How do we weigh how much of the prize money we grant to each conjecture?
I need 2 million now. No, I think that's a good question to discuss here. I think we should weigh them by importance for our project, our ecosystem. Maybe Giacomo, can you like list down the conjectures and we see how many we have, and then we can sort of
Yes.
see how we want to weigh them, or
Like the conjecture, yes. What's the best way to do it? So in reality, we only have like in the moment I have 3 conjectures in this paper, which are related. So I don't know if this is what we want to finally go for, but basically, okay. So let's first go to list decoding, which is at the top. So for list decoding, so this is the problem again of like I have a word and I want to figure out how many code words are in a ball at a distance delta from it. And there are like two settings that we're kind of interested in. There's the one of conjecture 3.5 and conjecture 3.6. What's the difference? Well, 3.5 is for the large alphabet regime, while 3.6 is for the small alphabet regime. So we know that in the, I think there's a counterexample in our paper by Vastig and Ellie, like from 2005, I think, which tells you that like if you're working over fields where the characteristic is 2, you're actually able to get like you know that the numerator of like the list size will depend on the code word length in some way. So there's this factor of n.
Can you zoom in, please? For the old people.
So so notation list of the code at a distance blah. And we know that for the large alphabet, for the small alphabet case, this is the best that we can opt for, which is basically that the list size depends like in some way, probably zero, probably imagine it as bigger than 1, on the evaluation domain size. So evaluation domain size for most of the things that we care about is between 220 and 230. So basically, yeah, here you have like 30 bits of security you lose, give or take. If you go instead go above, so for some context, there's been like a lot of progress recently in like understanding the list decoding size of randomly punctured with Solomon code. What are these? Well, usually with Solomon code, I have an FFT-friendly domain. So I have a root of unity, and then I evaluate things over that. You can also think of like, there is Solomon code where like I pick at random, like a subset of the code, of the field, and then this is my code. So in that case, in this probabilistic setting, we're able to get some, if you go a little bit up, yeah, we get this thing here. This is proven. This is proven that for like randomly punctured with Solomon code, as long as the field is large enough, in this case like linear plus a little bit in the, that's a lot, it's a theoretical result. We know that the list size of the code is like this.
But then the conjecture, you want them to prove it for any evaluation domain?
So I would care about FFT-friendly evaluation domain.
So any FFT-friendly evaluation domain?
Or all evaluation domains would be enough.
Yeah, all evaluation domain would be enough, but if they can like...
No, but to prove, if they prove
if they prove for all, then that implies, of course.
No, but I'm asking if they prove for one. They say, here's the evaluation domain, it's not a randomly punctured one, it's a specific one, and they prove the conjecture.
Yeah.
It's structured. I think like the right word is like structured domain. No, we're interested in structured domain. Like
So the random ones are just non-constructive. They don't even tell you which domains.
Yeah.
Yeah. So you're
it's
saying
not, it's constructed, just random.
but then it's easy to do what you said. You just pick one of the ones that come out of the.
No, but then it's gonna be like for every n, you have each
Oh,
other
but it
to
depends
hypothesis.
on the.
I want to show something that there's a infinite sequence, right? If you're not doing something for a specific parameter.
Yeah.
If you need to show me that. No, so it's not clear now what is the conjecture because L is now not.
Yeah, absolutely, absolutely. This is one of the things that we need to figure out. Like, in my opinion, we should like, so there's a few options that we have. So at the moment here, I said like, the same result holds for like some smooth evaluation domain where L is some arbitrary root of unity of like the field. This is the setting that we typically care about. Sometimes we care about causes of that. I'm not 100% sure what's the right way to do it is because one thing we could do, we could like say, look, we care about koala bear over like koala bear, and we pick one root of unity of koala bear, maybe 7. I don't know what the roots of unities are, and then we just say like prove it for that. For a mathematician, this is not exactly what they want to see. Like
yeah, the more specific you make it,
exactly.
less attractive it would be.
Yeah.
It could ask you to prove it for a smooth domain.
Yeah.
But I don't know, maybe the fact that you choose the domain at random, maybe it has some probability of being smooth.
Yeah, so maybe
then
then
actually you could get that.
if we say the probability maybe of a smooth is greater than 0, and then you're like,
If it's a random smooth domain, are we happy? Like amongst all smooth domains, if it's like
I think so. Like, look, as long as
Isn't there there's a unique subgroup of each order in a cyclic group, right? So what do you mean random smooth? Is there just one? Each particular power of two sides.
wait.
Evaluate all.
Yeah,
Well, a smooth subgroup or subgroup.
Yeah, subgroups are single ones.
Yeah.
And then
it's debatable.
Yeah. If you're a subgroup, you're fine. You know, I don't think we should think about college. College seems like
the whole field.
yeah. Yeah, we can say like for an arbitrary like cyclic subgroup of the field,
It's the same.
we like what you prove it. Maybe it makes sense.
Giacomo?
True.
You don't really care if you have one of them specifically because anything interesting is likely to be more generally improved technique. Maybe some specific structure, but more than non-field.
I think it's not the same, right? Because like for constants, your argument was yeah, but I think there's a significant difference. That is, for constants, you say things will get better and constants improve over time. I feel like if you have a proof for one specific field and specific evaluation domain, then this tells you nothing about a different
No, I think what I mean is that like what we're more interested in is a like general proof technique that works. Right. And
But
then,
it may
like
be
the generality, like the
specific
fact that
to
the
that.
proof techniques work will be hopefully independent of like one specific field. It might be tied to some specific algebraic structure or something, like not a specific field.
Yeah, maybe not the field.
Yeah. What I'm like kind of worried about, really, about the collaborator is that a lot of the probabilistic techniques that we have require a relatively large field. Like maybe sometimes a very large field. Like, you know, these are theoretical results, there are constants which are not great. So if you look at the one that I had before, that like something like 2 to the 20 divided by eta, you know, this is much larger than what we have. So there is a chance that when we end up like working with this kind of thing, we end up getting results for like fields which are like too large. So, and this will not transfer. Like for example, if I give you like a proof for fields greater than 2 to the ball 100, you know.
Do you mean characteristic? Because of course we always can use extension fields.
Yeah. I mean a characteristic. Yeah.
Okay, so I think we are at time. So thanks all for this session. I think we will have a proximity jam session. I think tomorrow. Or
After tomorrow.
Day after tomorrow. Okay. So we can continue these discussions there. I think this session, the proximity session, was planned to be pretty like open. So yeah, you see the questions. I put some notes there. This is from the HackMP that you should have, and we can continue the discussion then. Thanks a lot.
We have to take away from the session.
I think we.
There's gonna be some report.
I think we have some takeaways. They are.
That we write that it's like the
But I think the
decision.
neutral thing is like what you were saying was like, you know, with the Millennium Prizes, like the clay people don't have like some very strict set of rules.
Yeah,
to do,
exactly.
Right?
That's
There's a
the
sense
most
like if it's gonna
important
work, it's gonna work, and you know, we'll figure out if we think it works.
So I think this part is kind of a takeaway, right?
No, but I'm saying like it's related.
So yeah,
Like I don't think we need to try and specify like the very precise exact parameters other than like then we should have like a spirit of what we expect as well, just well clearly formulated. And then that avoids the most equal standard and trying to find it completely regulations.
Okay, yeah. So I think takeaway. I think this was a clear takeaway. How to advertise it. I think we made some progress there. I think we are now. We know there are much more details about how to specify what the conjectures are. I wasn't expecting that we figure out these details today, but I think we made progress. And also the spam protection, I think there was some.
That we solve the conjecture, right?
Yeah, that would be great. Let's do that day after tomorrow. Okay, thanks a lot.
How was the trip? Had some trouble?
I think you're right on the plan. That's the way to do it. Every time I come across a container, I forget what they are. That's even two things to say.
We can discuss that. Just starting like European submissions on and that's going to use this. As well, for example, I think I proved that actually numerically, I don't know how to we're gonna be fine.